All right, so today we're going to continue our work on writing equations. I'm going to go through a quick review here of the work with writing equations that we have done in the past and talk about that a little bit. This follows the notes for writing equations, the last lesson, and then we will get into some more information about writing equations. So remember that I can be given different pieces of information, and if you remember, some of them we wrote in the form of y equals mx plus b, while others we wrote in point slope form, which is that y minus y1 equals m times x minus x1. Okay, so we're going to use those two different equations here on these four types of problems and write the equation for that line. So on number one, it gives us the slope and the y-intercept. So I'm going to choose y equals mx plus b. So I'm going to put y equals 1/2 x plus 8, and that's my equation because the m is 1/2 and the b is 8. On number two, they give me a graph, so I need to go find the slope and the y-intercept. If I look at the y-axis here, I see that that line crosses at -1, so the y-intercept is -1. And if I go find another perfect point, I see one there. I would have to go down 2, which is -2, and right 3, which is +3. So my slope is -2/3. So if I have my m and I have my b, I'm going to write that in slope-intercept form. So y equals -2/3 x minus 1 would be the equation of that line. Okay, moving on to number 3 here, I see that they give me the slope, which is m, and they give me an ordered pair, so x1 and y1. So those three things are in that point slope form. So I'm going to go ahead and write that equation. So y minus the y-coordinate, which is -2, put that in parentheses, equals m, which is -1/2, times x minus the x-coordinate, which is -4. So there's some simplifying I have to do here. But my equation would be y plus 2 equals -1/2 times x plus 4. So there is the equation of that line that has that slope and goes through the point -4, -2. On number 4 here, they give me two ordered pairs. So I'm going to go ahead and find the slope. So I'm going to use that y2 minus y1 over x2 minus x1. So if I label my ordered pairs here, there's point 1, there's point 2, and now I can do the math. So I have 2 minus 5 over 0 minus -3. So I have -3 over +3, which is -1. And then I'm going to choose one of those points. I'm going to choose the first one, so -3, 5. So I'm going to use point slope form since I have a point and the slope. So y minus 5, since that's the y-coordinate, equals -1 times x minus -3, which now I need to simplify. So y minus 5 equals -1 times x plus 3 is the answer there. Okay, so just a quick review, kind of some work on how to write equations. You're going to see that we're going to use point slope form today in our writing of our equations. So we reviewed writing equations. We're going to learn about parallel lines. We're going to learn about perpendicular lines, and then you will have some practice. So first of all, I need to know the characteristics of parallel lines. So hopefully by the end of class you'll know that. And then we're going to learn to write the equation of a line that is parallel to another line. Okay, so hopefully you'll be able to do that. And then we're going to do the same thing for perpendicular lines. All right, so just take a look at these three equations and tell me what you notice. Okay, some of the things you should have noticed is that they're all in that y equals mx plus b. They all have that slope of 1/2, but their y-intercept is different. Okay, so some things to jot down in your notes here about parallel lines is that they are lines with the same slope. Parallel lines have the same exact slope. They have different y-intercepts. They're at different locations on the graph, but on the graph they will never intersect. They're those two lines that run right beside each other, having that same slope. So here's a visual of that. So these are parallel lines. If I look at their equation, you see that they do have the same slope of -4 here, but they have different y-intercepts. So because they have that same slope, they do run parallel to each other. Okay, so we're going to go ahead and find the equation of a line going through a point and get parallel to a given equation. So I want to make a line that is parallel to y equals -2/3 x plus 8. Well, if I know it's parallel, I would know that they have the same slope. So the line parallel is going to have the slope of -2/3, just like this equation. However, it is not going to have that 8 as the y-intercept. They have to have different y-intercepts. But I know that it goes through the point 3, -5. So if I know the slope and I know a point, I can use point-slope form. So I'm going to write my equation in point-slope form, which is y minus y1 equals m times x minus x1. Okay, so y minus, I put -5 because that's the y-coordinate of my point, equals -2/3, that's the slope, times x minus 3. And now I need to simplify, so my final equation is y plus 5 equals -2/3 times x minus 3. And there is the equation of that line. That's a different equation, but it is parallel to that y equals -2/3 x plus 8. Okay, let's take a look at another one here. Find the equation of a line going through the point 4, 1 and is parallel to y equals -3x plus 7. Well, again, if it's parallel, I know that has the same slope as this equation, but a different y-intercept. So my slope of my new equation, or my new line, is going to be -3, and it has to go through point 4, 1. So now, because I have a point and the slope, I can just write that in point-slope form. So y minus 1 equals -3 times x minus 4. And that is the equation of the line. Okay, moving on to a third example here. Find the equation of a line going through the point -2, 7 and is parallel to 3x minus 4y equals 15. Okay, so again, I want it to be parallel to this equation. Now notice that equation is not in slope-intercept form this time, but remember, we know how to find the slope from standard form, and that is in standard form. So remember, the slope is the opposite of a over b. Okay, well, a here is 3 and b here is -4. So if I write that, I'm going to have -3 over -4, which is positive 3/4. So the slope of my line needs to be 3/4 since it has the same slope. Okay, and then it needs to go through point -2, 7. So writing it in point slope form here, y minus 7 equals 3/4 times x minus -2. Simplify here, I get y minus 7 equals 3/4 times x plus 2. And that would be the final equation of my line. Okay, let's do another one similar to that so we kind of get back in the habit of finding our slope from standard form. So find the equation of a line going through the point 10, -2 and is parallel, okay, to 2x plus y equals 8. So remember, I need to get the slope because parallel lines have the same slope. So here a equals 2, b equals 1, and remember the slope from standard form is the opposite of a over b. So that's going to be -2 over 1, which is -2. So the slope of my parallel line is -2 since that slope is -2. Remember, parallel lines have the same slope. And then it needs to go through 10, -2. So y minus -2, that's the y-coordinate, equals -2, that's the slope, times x minus 10, that's the x-coordinate. So to simplify here, I have y plus 2 equals -2 times x minus 10. And that is my final equation. Okay. All right, so I'm going to go over some special cases here. Remember, we have some lines that end up being completely horizontal or completely vertical. And I want to talk about how to write the equation of that. So what if it asks us to write an equation of a line going through the point 2, -3 and is parallel to y equals 9. Well, remember, y equals 9 is something that looks like this, and the slope of that line is 0. So if I want my new line to be parallel, it has to have that same slope. So I need to use the slope of 0, and it has to go through the point 2, -3. So plugging that into slope or point slope form, y minus -3 equals 0 times x minus 2. Okay, so remember the right-hand side, this is just going to be 0, and over here I get y plus 3, but now I need to solve for y so that I have it in some kind of equation form. So -3 on both sides, and I get y equals -3. So my equation is y equals -3. And of course, it should just be y equals a number because it is parallel to the other one, which was y equals a number. Okay? All right, taking a look at another example here then. Okay, so I want to find the equation of a line that goes through the point -410 and is parallel to x equals -2. Now remember, the slope for x equals -2, that's a special case, is undefined. It goes straight up and down. Okay, so if I want my line to be parallel, it has to have that same slope, and it has to go through -410. Okay, well, if I look at my equation, it was x equals -2. So I know it's going to be x equals, and then my question is, what x value do I use? Well, go look at my ordered pair here, and the x value is -4. So the equation of the line that is parallel would be x equals -4. X equals -4. All right, so that is our notes on parallel lines. Let's go ahead and learn some things about perpendicular lines. Okay, so take a look at these two equations. Do you notice anything about those equations? Okay, when I look at those, I notice they are both in slope-intercept form. They have different y-intercepts. And if I look at the slopes here, they're not the same anymore. One is positive and one is negative. And it looks like they have the same numbers, but they flipped them around. Okay? So just some things to jot down about perpendicular lines. It's very important that we understand that instead of having the same slope now, they have opposite reciprocal slopes. So for example, if the slope of one is -4, the other is going to be positive 1/4. Okay, so they're going to be opposites. So one will be negative, one will be positive, and then they have reciprocal slopes. And then on the graph, they will intersect this time, and they will intersect at a 90-degree angle, that right angle. That's what perpendicular is. So that would be like, an intersection on the road, where you have a stoplight. We have to have that stoplight because people would intersect with each other if we didn't have one direction stopping. Okay, so here's a visual then of perpendicular lines. So again, notice they have different y-intercepts here, and their slopes are opposite reciprocals. So one is negative and one is positive. This one up here would be 2/1, and then we flip the other one to 1/2. So they have opposite reciprocal slopes, and they do intersect at that 90-degree angle there. Okay, so we've talked about parallel lines here. They do not ever intersect. They have the same slope. We're talking about perpendicular lines now. They do intersect at that 90-degree angle and have opposite reciprocal slopes, but not every single set of lines has to follow those two rules. We could just have two lines that intersect at some different angle, and you'll talk more about work with that when you take geometry. Okay, so let's go ahead and write some equations of some lines that are perpendicular. Okay, so find the equation of a line going through the point 3, -5, and is perpendicular to y equals -2/3 x plus 8. So remember, I can't have the same y-intercept, and this needs to be an opposite reciprocal slope for my new line. So this one is negative, so my opposite reciprocal is going to be positive, and then the reciprocal of 2/3 is 3/2. So the slope that I want to use is 3/2, and then I want it going through the point 3, -5. Okay, well, if I'm given a point and a slope, I'm just going to use point slope form. So I'm going to write y minus -5 equals the slope, or m, so 3/2 times x minus my x coordinate, which is 3. So now to simplify, I have y plus 5 equals 3/2 times x minus 3. And that is the equation of a line that is perpendicular to the one that they gave me. Okay, take a look here at another example. So find the equation of a line going through the point 4, 1 and is perpendicular to y equals -3x plus 7. So again, if it's perpendicular, I want the opposite reciprocal slope, okay, which this one has a slope of -3/1. I want to make sure to turn that into a fraction. So if it's the opposite, it would be positive, and then the reciprocal of 3/1 would be 1/3. So the slope that I want to use is 1/3, and then my line has to go through the point 4, 1. So again, if I have a point and I have a slope, I'm going to put that in point slope form. So y minus 1 equals 1/3 times x minus 4. And there's no simplifying there, so that is the equation of my line. Okay, take a look at this example. Find the equation of a line going through the point -2, 7 and is perpendicular to 3x minus 4y equals 15. Okay, well now I have a standard form equation, so I have to find the slope of that equation and then find the opposite reciprocal. So remember, my slope for standard form is the opposite of a over b. So a is 3 and b is -4. So it's going to be -3 over -4, which is 3/4. But now, because it's perpendicular, I want the opposite reciprocal, which this one was positive, so mine is going to be negative. That's the opposite. And then the reciprocal of 3/4 is 4/3. So the slope that I want to use is -4/3, and then I want it to go through that point -2, 7. Okay, so I'm given a point in the slope. I'm going to write that in point slope form. So y minus 7 equals -4/3 times x minus -2. And I do need to simplify that. So y minus 7 equals -4/3 times x plus 2 would be my equation of my line. Okay, one more example here like that before we get to our special cases. So find the equation of a line going through the point 10, -2 and is perpendicular to 2x plus y equals 8. So again, I need the slope from this standard form equation so that I can then find the opposite reciprocal because I have a perpendicular. I want them to be perpendicular. So remember, the slope is the opposite of a over b. So a here is 2, b here is 1. So that's -2/1, which is -2. Okay, but I now want the opposite reciprocal of that since I want it to be perpendicular. So the opposite, that was negative, this is going to be positive. And the reciprocal of 2, which is really 2/1, is 1/2, which is 1/2. So the slope that I want to use is 1/2, and I want it going through that point 10, -2. So again, because I have a point and the slope, I'm going to use point slope form. So y minus -2 equals 1/2 times x minus 10. And I'm going to simplify, so I get y plus 2 equals 1/2 times x minus 10. And that is the equation of my line. All right, let's go ahead and look at some special cases here then. So the first one says, find the equation of a line going through the point 2, -3 and is perpendicular to y equals 12. Well, remember, y equals 12 has a 0 slope, so it looks something like this. Well, if something is perpendicular to that, it's the opposite of that. It's going to go straight up and down. And if you remember, the other special case is that straight up and down. So instead of y equals 12, I want x equals, and now I need to look at the x coordinate on the point that they give me, and it's 2. So my equation that is perpendicular to y equals 12 would be x equals 2. Okay, the next one, find the equation of a line going through the point -410 and perpendicular to x equals -5. Well, remember, x equals -5 would be straight up and down. If it's perpendicular to that, it has to go left to right. So instead of x equals, it's going to be y equals, and now I look at my ordered pair and they say the y value is 10, so I'm going to say y equals 10. So y equals 10 is perpendicular to x equals -5. Okay, so go ahead and click on the practice in the Canvas assignment and practice those. Go ahead and use your notes, but make sure to try to complete those problems to get some extra practice writing those equations with those parallel rules and the perpendicular rules.